Right. Good morning, everyone. Can you hear me?
Yes, sir.
Okay. Thank you. Last time we look at software engine design. This is the revisit of what we have discussed in business analytics and software design. The idea of revisiting this is before we move on to more advanced topics, we make sure that you have a good understanding about the software design and modeling tools. So the very first thing that we have discussed is data flow diagrams. Actually, there are a couple of diagram tools we will use throughout this. Um, Basically, we can look at data flow diagrams and process modeling diagrams, UML diagrams. So these are all we use to convey our design to our users, different types of users, uh, for top management, even to share the design with our colleagues, right? It's very important that you are familiar with these set of tools. So depending on the software practices, some software development companies may use uh, some of these tools, or then there may be different ways to do that. But generally, we should be familiar with these different types of modeling techniques. Now, under this one, the last time what we decided, we started looking at the data and process modeling again. And those who have done A levels, you have already have done this, but there are slight changes of the notations. For example, the notations that we have used here is this first set, whereas some other places, there are other notations are also used. But since I'm referring the book, the textbook, so I'm going to use the first set of symbols for data flow diagrams. Now, what we have discussed last time is about different levels of data flow diagrams. The higher level, we call it context diagram. In context diagram, usually you will have a single process which represents your whole information system. And there are some numbering system also we use. So usually in the context diagram, the number we use is 0, which indicates that it's the topmost, the representation. And what you see in usually in the topmost diagram is you will have your, we have only one single process which represent our software system, and all the external entities, which means they could be some others who interact with the system, that could be persons, or that could be some systems itself, right? So for example, here we have another system which interact with this system. So that is the first thing you need to clear out when we are working with the context diagram. Now, once you design this, then you can actually go into details, right? So that is what we sometimes call uh, going into details. We sometimes call diagram 0 DFD. So the idea there is now you can have like more processors, right? You can have more processors in this particular case. In this one, we can see uh, for example, here, the idea is like when you have a single process, which is what you see in the context diagram, then you can identify series of, sub processors with this process. Now, one thing you need to remember, there is always in and outs, like in this particular K and AB, so which will be similar for these sub processors as well. Again, here the F4 you can extend. So the F4, the inputs are X and Y, the output is Z. So it which will be the same. So remember that when you are drawing DFDs and context diagrams, keep this in thing in mind. where you have to make sure that your ins and outs are matched when you create sub-processes. And that's what we have seen in even in the interactive session as well. Right. Now, going back to our grading system example, we have external entities, and then we have all the data flows. And another thing I want to highlight is what I have noticed, for example, with your seniors is here it should represent only the data. There's no words you see here. It says graded work, submitted works, class roster, grade report. So it's very important. So each of the data line, what we represent here is what data you transform here to here. For example, from the grading system, what students is going to receive is their graded work. So simple as that. So you have to be very clear about, for example, what data actually, that's why we say it's a data flow diagram. Basically, the data flow among the system, the processors, and the external entities, and so on. Now, when you go to diagram 0, which means you go into deep of context diagram, you are going to represent your single process with multiple sub-processors. So right now what we have is the grading work, which is one single process. But then here what you notice is that single process is now put into 3 separate sub-processes. And what you need to remember is whatever the data flows should be here as well. For example, here we have an order. There's a process, there's a data flow from customer to order system. So that you need to see from here to another sub-process here, right? So that should be there. Okay, and then there's a order reject notice coming from system to customer. So this time order reject notice is actually coming from the first sub-process, right? Then there's a picking list going from system to warehouse. So you can see the first sub-process, it goes from picking list from first sub-process to warehouse. So similar to that, if you carefully look at all the data flows which you have seen in the context diagram should be here as well. So make sure that when you draw both context and diagram 0 DFD, you have to match everything. Right. By the way, remember now we are supposed to have mid-semester examination. So hopefully I'm going to allocate 1 hour for hopefully next week or week after that. I will put the information on LMS. So make sure that, whatever the materials we have covered so far will be evaluated in your mid-semester examination. And I will also share you some of our previous mid-semester examination papers. So make a note of that. Right, now we were discussing about the context diagram and diagram 0. Diagram 0, now we have seen, we have set of sub-processes which replace the main process. And remember the numbering. Now we started the context diagram putting 0 there. And here you can see we have started putting 1, 2, 3, and so on. Again, very important when you draw, you have to focus on the numbering. Now, apart from what you have here, the processors, external entities, and the data flows, you will see data stores as well, right? Data stores means whatever the data you are going to store, right? For example, here, when you create invoice, so that is recorded under accounts receivable. So similar to that, one of the difference between the context diagram and diagram 0 is, so in context diagram, there's no data stores are used, but here you can see we have a data store. Okay, any questions from this? So remember, you can type whatever you want. So remember to keep that information. Okay, right, let's go back. So given a problem, when you ask to draw context diagram and then diagram 0, so make sure that you understand this one, right? It's very important that you understand this, the requirement, and also the data flows. I told you like the data one. So the whatever the transferring the data flow, you should mention only the data that you are going to transfer among these external entities and the process. Very important. Otherwise, most of the time, what I notice is sometimes some of them they don't really understand the main ideas, because it's very important you understand the main concepts why we are using this, because I told you this is a diagrammatic tool, and how you are going to transfer this into code, we can have a session on that. Because why we are draw this like a flow chart, we should be able to convert this into a piece of code, right? So hopefully now in this particular case, what you could do is you can convert all these processes into, for example, as functions. So there should be a purpose why we are using these diagrammatic tools. So make sure that you understand that. Okay. So let's move on. Now, when you look at getting lower level diagrams, there are two ways we can talk about two ways of creating low level diagrams, right? The first one we call leveling or exploding. The meaning of this is you have the process of a series of increasingly detailed diagrams. So hopefully when you go into level, right, you have more details, right? So that's the whole idea that we would like to have, right? So you will have more information about this, right? Then so there are few things we use around this term. When you say leveling, it's also we use the term exploding, partitioning, or decomposing. So you may use any of these, right? So remember that, it's very important. Right. Next one is what we call the balancing. When we say balancing, basically you have to make the consistency, right? And your input and output should align properly. So those are the ideas that we have to uh, think about. So which means in graphically we have noticed this, whatever the data flows in the external, in this particular case externally, that should be maintained when you go into go into details. So that means here we have input A and B. So when you go into sub-processors, you have to have A and B, right? So that's the idea of, balancing, right? So if you want to go more, right? Like, let's say this is like the level 0. So let's say you want to go more into details, then the numbering slightly change. Now, for example, let's say we want to, create set of processes to understand what is happening during the fill load, which looks like this, right? So you can see here, now it's numbered as 1.1, 1.2, and 1.3, which indicates that it's basically extending the one from the previous level, right? So this time you can see more information, right, about the sub processors within the field order, right? So that's how we will go into detail. So in examination perspective also, so you should be able to understand when you're asking a context diagram, you have one single process, no data stores, but when you go to level 0, then we can have additionally from context diagram, you will have data stores. Again, you can go more into details, right? So so this way you can show as much as details you want. Right. So this is simply the mapping from original into getting into details. So you should be able to map all the inputs and the outputs. Right. Now, two more things we discuss under data flow diagrams are, we can talk about data dictionaries, which is where you can store information about the system data. Right. So in data dictionary, we can collect all the facts about the system. So you can have the content of data flows, the data stores, entities, and also the processes. So in this way, it'll describe all the data elements in the data flow diagram. So when we talk about the data element, we can call it as a data item or a field. So that will be the smaller piece of data that has a meaning within the information system. So if you take, for example, a student grade is an data element. Then we have data records, which is the combination of the data elements or the fields, right? So for example, you can have, if you take student record, you can have a student registration number, name, address, telephone numbers, and so on. Right. Let's discuss the next one, process description tool. Again, we have covered this topic from previous subject as well. So I'm briefly discuss. So when you have processes, especially with the information system, we should have a way to model it. Now, to model it, we can use various tools. The first one we call structured English, where you can, like a pseudocode, you can represent uh, what you call the process, right? So you can put it like this. For example, here, if you read this structured English, you will see for each order. So that means you are going to make an iteration. If customer status code is yes, which assuming that customer has a good credit score, or maybe he will pay on time, and product details okay, which means the product is in the store, then we can accept the order. If both of them are not accepted, let's say customer's credit code is bad, then no point that giving the order, or a product is missing or product is not available, then it's not going to work. So that's a simple structured technique to represent processes. Then we can put the same information as a table. So for example, in this table, what you see here is called how we actually accept an order. So there are two conditions given to us. The order will be accepted only if the product is in stock and customer credit status okay. So that means we'll accept the order when both conditions are set to true. and any of these are failing, then we are not going to accept. Basically, we are going to reject the order. So simple data structure can be represented like this. But then if you need like more examples or more simplified graphical representation, we can use what we call decision trees. So this decision tree actually represents the same thing that we have put out in the decision table, right? Your conditions, actions, and the rules. So it will be mostly a very compact representation, so which is easier and which is preferred, right? Okay, so those are the things that I would like to discuss under this topic, right? So I will have a separate session on discussing how we can use the outcome of data flow diagrams put into a code, right? Um, Let me continue my today's topic, which is we are going to basically going to look at in detail object oriented design, right? The idea is we should understand the OOP concept. Basically, object orientation is can be considered as one of the development techniques, right? So we have to have a good understanding about OOP concepts, which I think it's must for, let's say, if you go for your internship or even for interviews for the job opportunities, you should have a good understanding about these principles, right? So let's start how we can uh, use object modeling. Sorry. So object-oriented, the design principles are around with the OP languages like Java and Python. So, and many, sorry, many programs prefer object orientation because once you properly set up this, it will be modular, well structured, and then you will have a reusable components, and also it's easy for you to maintain the software. So how people design an information system using OOP is you have to identify what we call the objects, right? Which could be a person, a place, or event, or a transaction. So it's a different way of modeling and implementing. We know this as a different software paradigm. So let's say patient management information system, and let's say we want to make an appointment for a meeting with the doctor. So we can see that there are at least two persons are interacting. We have a patient and we have a doctor. So we can represent the patient as an object and doctor as an object. And if you take the appointment, so that is also an object. So in OOP, we will see any system as a set of objects, and objects, you have different functions and there are ways that you interact. So the end product of this analysis is what you get, what we call object model. And this object model, in object model, which represents the information system, which uses the ideas of objects and also the various object-oriented concepts. Okay, again, a small question. Right. Now, these are like, say, things that you have already known, but from the textbook. So let me briefly go through to understand ideas of, let's start with objects. So the object can be a person or a place, event, or even the transaction, which is part of the information system. And then when you say an object, you have to have data and also the processes, right? So for example, here they say if you take an customer, you can have name, address, account number, and current balance and so on. And then customer objects, you can also perform specific tasks, things like placing an order, paying a bill, or changing the address. So you can see here, we have a parent object, which we have parent, then we have a set of attributes, and we have set of methods. For each of these, we can create instances which has different values for each of these attributes. For example, the name is Mary Smith for the first part. Age will be 25, and then a female with red colored hair, right? So which is the instances means and use assign the values to these objects. Right. Let's move to the next one. Another example, we have child object. We have attributes, the methods, and then we have some values. Okay. Now, let's do some coding exercise. Maybe we can start with the previous one, right? Okay. Can you, okay, we'll do like this. So right now what we have is a parent object. We have name, age, sex, and hair color. Two methods, read bedtime story and drive in the carpool. Let's put up some string values here. So maybe I can say, okay, return, let's say, will output as a string. So maybe I can say, okay, self dot name. That means whoever the person, we will say, okay, is reading a bedtime story, right? So that's one thing you can do. Similar to that, let's return again F string. Again, I will say the same thing, self dot name. Yes, is driving in the car. Right. So which will describe this? So this is the class which we can use to create the instances. So let's create some instances then. The right now, okay, we have the first one. We have Mary Smith, age is 25, female and red, right? So once we create the class, let's make use of class. So what I can do is, right, we can create an instance. Okay, we'll say Mary Smith. So we know that this is from parent class. So name is Mary Smith, and then age is 25. Gender is female, right? hair color, let's say red. So this is how we will use it. So let's print the information. Now we have created the instance. We assign these values. So let's output, right? Let's display the attributes. So what we can do is we can say print, let's say, okay, like this. Maybe we can say, okay, maybe we'll have single print statement. Okay, to display the first one, let's say what is name. We know that we have to get Mary Smith dot name. Yep. So let me save the code. File save as. We have where is our postcode? Okay, advance software design. Right. Let's say program 1 OP. We'll put it that way. So let me run this. Run module. Yeah. So basically we are getting this, right? Only Mary Smith is there. So let's put the other information as well. Print F, let's say age, Mary Smith dot age. Print F, we have sex. Mary, okay, we have mistakes here. Dot in print hair color. So we have hair color, we have Mary Smith. Dot, let's say, what do we have? Yeah. So let me run module. Okay, so what was the error? Okay, so I forgot. Run module. Exactly. So you can see now we have stored, we create the class, we create the instance, and we store these values, and now we are accessing. So let's finish this by creating method as well. So what we can have is, let's say, we'll use class methods, use of class methods. So we can say print Mary dot Smith dot read bedtime story. right? Similar to that, print Mary Smith. So when you run this, again, okay, we forgot this. Additional extra. Yes. So you can see if you done it properly. So you should get some information like this. So we created the class. We initialize it by passing the values we get from the user. And here is how we represent your attributes of the class and also execute the codes. Okay, those who have finished, can you please raise your hands? Yeah, finished? Let me go through the code one more time. So what I did basically, based on our document. So this was how we started. We created the parent class, and then we create the instances, right? So during the initialization, we are passing name, age, sex, and hair color, which will be stored as attributes. And then we also created two methods to demonstrate how to use this. Right. So that's what we have discussed so far. So let's move on to the next one. Now here is another object. We have a child this time, right? And you can notice that apart from parent, you have some additional attributes. At the same time, you have a different set of methods, which is slightly different from the previous one. So I hope that part you can do. Similarly, you can see talk object, right? And then when you say doc object, again, you have a different set of attributes and you have a different set of methods, right? And some instances are there as well. So I hope that part you can do alone. Right. So the attributes that we have seen there, basically, you can inherit, acquire certain attributes from other objects. So you will also have specific attribute. So you can find, for example, object current status. So for example, if you take a student, that can be future student or a current student or past student. Similar to that, bank account can be active, inactive, closed, and frozen. Likewise, we can keep track of their their status, right? So in this example, you can see similar methods are there, but this is two different objects. Okay. And then we have another class which we call fitness class schedule. So you can see it here as well. Then we have a registration record. Right. So let's, in this example, you see a couple of objects, student and instructor. And then we have a fitness class schedule object, which is what we have in a place like a fitness, maybe a gym. And then you have some registration record, which is when you register in a gym, this will be created. And you can see we have a status as well. We won't keep track of the information. So the methods that we have seen under this is perform a specific task. And then you have a set of steps incorporate in this. Third one, the message. Now, object interaction, right? So the message can be used to tell different things for different ones, right? So you can see here we have a student, but when you have a message, we have add students. Then when you say add student, you will say student class to perform all the steps needed to add a student. Similar to that, we can say delete student. Then you say student class, right? All the steps to delete a student. Right. Now, if you look at the what will happen to the message, right? So depend on what message is passes to different objects that can, uh, you know, perform differently. So this is to say polymorphism, which means that there are many forms. So if you send a message saying good night to the parent, right? So that should, cause parent object to read a bedtime story, right? Dog, that might cause the dog object to sleep. Or you can also use child. It causes the child object to get ready for the bed. So this is another interaction that you can think of, right? Then After that, we also discuss about different classes. So these objects usually belongs to a group or a category called classes. So all the objects with the class share common attributes and the methods. An object within the class can be grouped into subclass, which are more specific categories within the class. So you can see here we have vehicle, right? In vehicle, we have a common set of attributes. And then we have subclasses, car, minivan, and truck, right? So you can see here. So which are actually subclasses of vehicles. And you can see some subclasses, you don't have anything new, car and minivan, but truck, you will have uncommon attributes. Yes, in school bus also you have. Okay, shall we have a very small exercise on this then? I want you to like our previous school. I just want you to spend some time. Okay, create a class vehicle and also create some subclasses using car. Shall we start? We can say class vehicle. So let's have the constructor. So we have self, we have make, model, year, weight, and color, right? So these are the attributes. Let's assign the values. Self.make equals make. Self.model equals model. Self.year equals year. Self.weight equals weight. Self.color equals color. Right. So this is basically what we have discussed so far. Right. So we have then the methods. So this is what we have. So we have three methods. Let's generate. Today we have def start. We have self. We can say okay, return. We can say okay. Yes, we say self dot make self dot model starts. Right. The second one we have def stop self return f self dot make self dot model. We'll say stops. Def park so we have park self. Right. Now this is about my vehicle class. Right. You can create a vehicle and then you can put it that. But now let's say we want to create a subclass from this. So the idea is we have to have, let's say a car. So what should happen? Ideally, we will say class, we'll say car, should be vehicle, right? And then basically we can have this, whatever the initialization you can put it, or you can simply, pass the value. So that's all what we need, isn't it? So you can execute things that you want to have, right? Otherwise, this will be the just the pass, right? So basically, this will inherit all the attributes and the methods we have in this class.